Hey everybody, it's Ripley back again. We're going to do a real quick, brief discussion about the algebra functions, in other words, how they interact with each other with respect to the way we think about numbers and other things that we've dealt with in the past. Functions can be a little confusing when you first start playing with them. Hopefully this isn't the first time that you've seen them. So just to give the discussion some focus, I'm going to let f of x equal x squared plus 3, and I'm going to let g of x equal the square root of x minus 1. Okay, now the algebra function, while it sounds really complicated, all it means is how do we group these things? How do we make them interact with one another? Let's say that somebody throws something like this at you. What is f plus g of x? Well, that's a notation that may send you screaming for the doors, right? Well, don't be afraid. All that this really means is just a notation is f of x plus g of x. Now, we got to be a little bit careful here, because if you think about this, what is f of x plus g of x? Well, it's easy, right? I just do f of x plus g of x, so I end up with x squared plus root x. I'm just adding them, and then I've got plus 3 minus 1, which is plus 2, right? Nothing to it. Now, you might want to evaluate things like domain. Did domains change as I combine these, right? It's just ways to combine functions. But we'll play with that in class some more. And we don't spend a whole lot of time in this course. You'll see more of that down the road in either your pre-calculus or your calculus class. Likewise, if I throw an f minus g of x on this guy, it just means f of x minus g of x, or subtract them, right? So I'll have an x squared, right, minus root x, and then I'm going to have a plus 3 minus a negative 1, and I might be doing this a little bit fast, but again, respect thy negative. Remember, this guy is just x squared plus 3 minus root x minus 1. So if it helps you to write them out, write them out. I mean, some people are very meticulous about that. I've been doing this a while, so I can do them relatively quickly in my head without making too many mistakes. All right, same thing. What if I do f times g of x? Well, this is the same thing as f of x. Whoa, excuse me, f of x times g of x, which is just x squared plus 3 time. Now this time I'm going to multiply it out, because otherwise I'll do stupid things. I clean this thing up. Ooh, x squared times the square root of x. Well, what is that? That's x to the 5 halves, isn't it? X to the 2 times x squared times x to the 1 half, because that's what the square root of x is, right? Is if I combine these, if I multiply them because they have common bases, I add the exponents. So I end up with x to the 2 plus a half, or 2 1/2. But we don't like mixed fractions this high up, right? So I turn that into x to the 5 halves, right? Minus x squared plus 3 root x minus 3. Likewise, if I do f divided by g of x, this is the same thing as f of x divided by g of x. Now there's a little caveat here, right? Because you may have something that exists in g, but it won't exist when I start dividing. For example, in this case, I have x squared plus 3 over the square root of x minus 1. Now, real quick, without beating this with a stick, look at the domain of this guy. I know that the domain of this guy is all reals that are greater than or equal to 0. In other words, x is greater than or equal to 0, right? So 1 works in this. The square root of 1 is 1. 1 minus 1 is 0. I can stick 0 in here and I'll get negative 1. But notice my problem here. I need to be really careful when I start dividing functions, because I lose values. Notice that x cannot be 1. Even though x was allowed to be 1 up here, it doesn't work, because now it's in a denominator, and I'll end up with the denominator of 0. Mwah, mwah, no good. Okay? So the moral of this sordid little tale is be really, really careful with your domains. They can throw you off in terms of what you're doing. In other words, just because I'm combining functions doesn't necessarily mean that their domains are coming along for the ride. I have to be a little more, to speculate a little bit more as I go through this and pay some attention. All right, now let's talk about compositions of functions. Those are really important. We'll talk about compositions of functions. Now, this is a way that, okay, we've got addition, subtraction, multiplication, and division, just like we would think about with real numbers, right? But what happens if what did I have? I had x, or f of x I think it was x squared plus 3, right? And g of x was root x minus 1. Well, when I compose functions with each other, it's not like there's one of the functions has a baton and the other one's playing music. Terrible joke. I know, Ripley. I got it. But what happens if I insert this function into this function? In other words, what if I say f of g of x? Now you may see this written as f and this big kind of circle looking thing of g of x. They're identical. I like this one better because for me it's more intuitive. It's also easier for me to figure out what's going on. Now what does this say? When I teach this, I teach what's called, what is the dominant function? The dominant function in this case is f. When everything's said and done, f rules. Literally, it is the rule that we're applying. Now, what's this guy? This is g of x. So this thing right here in words says, wherever I see an x in f, stick g of x in for it. In other words, substitute it in. So we're not going to panic. This is g of x. More specifically, this is g of x. This is g of x's name is g, right? But the rule is root x minus 1. So watch. Wherever I see an x in f, whoop, there's an x right there. Wherever I see one, I'm going to do f of g of x. I see an x right there, so I stick this whole term in for it. So I've got the square root of x minus 1 squared, because this thing was x squared, and then 3 is not an x, so it's just along for the ride. Now if I want to clean this thing up, watch what happens. I can multiply this out. It's just a binomial expansion, right? And if you don't get what I'm about to come up with, come talk to me later. The square root of x squared is x. If, in other words, think of this as root x minus 1 times root x minus 1, right? So I end up with x minus 2 root x plus 1 plus 3, affectionately known as x minus 2 root x plus 4. Now, what if I compose them the other way? What if I do g of f of x? Now, journeyman mathematicians might say, well, why isn't it the same thing? Well, because the dominant rule has changed. The dominant rule is g. G wins. It says, okay, this literally says, wherever I see an x in g, let me change colors. Wherever I see an x in g, there's an x right there. Stick f of x now. Now, students often freak out about this until they get comfortable with it, but there's really no difference in what we're doing between sticking a number and sticking a function. Heck, if we wanted to, we could do g of Ripley. Wherever I see an x in g, stick a Ripley, right? It's just a rule that assigns these x values to y values. All right, so there it is. There's an x in g. Here's f of x right here. So I'm simply going to say, okay, wherever I see an x, stick an f of x. So I'm going to have the square root of x squared plus 3. See what I did there? The square root's not an x. It's just along for the ride. Stuff this x squared plus 3 in wherever I see that x. That's where this showed up. And then minus 1. It's just a rule. Wherever you see an x, stick the thing that's inside of the dominant function. Nothing to it. Now let me give you one more little juicy one. How about I'm going to add a function. Let's let h of x be 2x plus 1. All right? Promise. This is the last one, and then I'm actually done with the section. We can roll on. What if I did f of g of h of x? Okay, let's see. Did I close all my? Yeah, I did. All right, now what's this say? The dominant, at the end of the day, the dominant function of f, or is f, excuse me. However, I need to deal with this g of h of x. So let's deal with g of h first. I need to know what g of h is, so when I'm done, I can stick it into f. Well, g of h of x, so I'm just doing this off to the side. G is the dominant function, and here is h of x. So wherever I see an x in g, stick this guy. So I end up with the square root of 2x plus 1, right? I stuck 2x plus 1 in for this h, right, or excuse me, for that x right there, and then minus 1. That's what g of h of x is. All right? So I'm looking at f of g of h of x. Wow, that's a lot of parentheses. And what that says is take this guy which is g of h of x, and stick it in wherever I see an x in f. Well, there's an x right there in f, and this becomes root 2x plus 1 minus 1 squared. Notice what I did. I took g of h of x and I stuffed it in wherever I saw the x, and then of course just hanging off the end is a plus 3. Now I can multiply this out if I wanted to, and what I would end up with, I suppose I should because I'm going to be that lazy this early, so I end up with 2x plus 1 because this guy squared is this, minus 2 times the square root of 2x plus 1, and then plus 1, right, because negative 1 squared is 1, plus 3, I get plus 4. Isn't that fun? And that's it. That's how we algebraically combine functions. We add them, we subtract them, we multiply them, we divide them, just like numbers. And then there's this extra little skill that we have in terms of compositions. Again, hopefully you've seen it before. But if you haven't and you feel like you need more work, you can always come up to me and we'll work it out. All right, I'll see you in the next lesson.